ask me at any time. You can send me a queries so that I can clear. So I'll share these documents with the organizers later so that it will be easy for you to follow. So based on the syllabus that has given for me, the content has been prepared, and every answers and the coding is made that clear way in that document. So if you follow the document, you will get that right. So I'll share my screen now. So in the earlier session, so I have stopped in the 7th program. So linear regression. So in the theory classes and all, they have taken linear regression. So regression is one of the important concept for identifying the ML algorithm. ML algorithm concepts like prediction. Mostly this will be used for prediction. Prediction cases we will be using this. In this linear regression, there are different categories are there. Single linear regression, multiple linear regression, polynomial regression, and the last one is logistic regression. These are their categories. The importance is that this is mainly used for prediction. For example, in the morning, I have shown you a data set, a sample data set. So I'll show that data set now. So for experimenting this, you can use your own data set. So please be clear that how many number of X variable and Y variable are required for every algorithm. Some algorithm require single independent variable and one dependent variable. Some requires two independent variable and one dependent variable. So for performing single linear regression, as discussed in the previous case, so one variable and one target variable is enough. Based on that, how it will be predicted, what is the actual value we have just seen. So second case is multiple variable regression. What is multiple variable is that instead of having single independent variable, we will take two independent variable. The same data set I can reuse, but in the first simple linear regression, I have taken only the X1 part alone. In that code, if you just analyze this code, you will be a bit clear. So assume that assume the file has columns X1 independent variable, Y dependent variable. Even though I am having both the columns, I have taken this one alone as my independent variable and I have taken for assigning. This is assigned to X and my target variable is assigned to Y. But in this case, I have prepared this data set so that it will be well suited for both dependent variable and independent variable of linear regression and multiple variable linear regression. In this multiple variable linear regression, so you can see the same set of procedures, sklearn model, train, test, split. This is a predefined function. What is the functionality of this train, test, split is that? So as I said, so this is the entire data set. This is the sample we have created. But in real time, we will be having some 1,000 records. We cannot take that entire 1,000 records for running a model. So the main and important point in machine learning is that you have to split your data set. You have to split your data set. That is certain percentage for testing, certain percentage for training. For example, this data set randomly. For example, consider this 15 as an 100%. From this, 80% I can do that for training, and 20% of the data set I can use that for testing. So likewise, I have to split the data set. Then only we can check the model whether it is working correctly or not. So we cannot give entire thing for training, entire thing for testing. That is not the correct way. So if you are having a data set, the first and foremost important point is you have to split the data set into certain number of percentage so that 1% is used for training and another is used for testing. In order to do that split, sklearn model is having a library. So train, test, split, just it will take some parameters as an input and it will divide the data set. And similarly, this also a linear regression model. I can implement linear regression. This linear, why previous program and this program is a linear regression, you may ask. Both are linear regression. Inside this linear regression, if you are using single variable, that is simple linear regression. If you are using both independent variable, then it is called multiple linear regression. That is the major difference. Only thing that get differs is that this part alone get differs. So in the previous program and this one alone get differs. In previous program, I have taken only one independent variable, but this name is multiple linear regression. Multiple linear regression is that two or more independent variable depends on one dependent variable. That is called multiple linear regression. So here this independent variables are x1 and x2. Both are be taken and it will be stored in x, and the dependent variable is y and it will be stored by. Similarly, I have to split the given data set into training and testing randomly. So this random state, I can give a random number such that this will be randomly splitted. I cannot say that first 10 I have to take and for training, last 5 for testing. No, not like that. This have to be do some random calculation. Random functions take some normal number and it will split the thing into a random way, so that 20 percentage will be used for testing and 80 percentage will be used for training. Then I have to fit the linear regression model. Then I have to train this will be splitted. X train, X test, Y train, Y test will be splitted separately. And the training data set will be given for the model so that the model will learn. So in order to give that one input to your linear regression model, this model variable dot fit. This model variable dot fit is nothing but, so here I have given linear regression. What happens on this line is, what are all the code that is written for linear regression model will be enabled and it will be stored in this variable. This variable now acted as the object for this linear regression model. So model dot fit. So this model needs some data set for training. Training is nothing but, if this is my x1, if this is my x2, this should be my y. If this is my x1, this is my x2, this should be my y. Likewise, the model itself has to learn on its own. That learning process is done by making this model to fit of x train, y train. So you have to make this model. So on this line, what happens is that linear regression model will be created, and this model have learned 80 percentage of data set. If this should be my x, this should be my x1, and this should be my y. Likewise, it will learn. And the next thing is prediction. So this is actual training. Next is prediction. So prediction is that based on, so this is from the given data set. Based on the model's own understanding and the formula it has learned, how it will predict the data for some certain set of x value. So that is x test value. So testing data set you have to given as input to your model. This will predict some y value. So I have to map this one, y testing and y prediction. What will be the actual tested value? What is the actual predicted value from the model? That will be plotted. So this is what is explained here. This is the actual y value for the tested data variable x. This line is nothing but the predicted value for that x. So we are mapping and visualizing. Oh, it is very clear. So our model is working in an accurate way. Likewise, for example, if this dot is located here, if this dot is located somewhere, this dot is located somewhere, but this line is located here, means this indicates is that your actual value is somewhat, your predicted value is somewhat. Those are not closer. Those are not nearer. So your model is predicting it in a wrong way. So likewise, we can understand. So this is for single variable. So if I have taken two or more variable, my prediction would be looks like this. This is the two-dimensional because I have taken x1, also I have taken x2, and it is evaluated across y. So it is the multiple linear regression. So the multiple linear regression is that this, if you want, you can draw this line, but it is not a linear surface to draw the line. It is a two-dimensional surface. So this blue color dot implies the actual value and the red color dot implies the predicted value. So from this picture, I can understand is that my model has more accurately predicted the value, which is very nearer to the top what the value is actually having. So this is called multiple variable regression. So what is the difference of this one is that, so in previous model, I have used only X1 along with Y. But here I have taken both X1 and X2. So this is the difference point. I have taken both X1 and X2 and it is evaluated against Y. So how I have to visualize? Both the things are need to be visualized. So first is scatter plot. Both are scatter plot. If you just give this plot, then it will be a line. If you just given some other thing, then line or some dotted lines will be there. So I have given scatter for both the cases. So scatter plot is available in this visualization. So the scatter plot is available for actual value and the scatter plot is available for predicted value. Both are represented here. So you can see here what is the error value calculated or square. These are all the things you have already studied in your theory session for linear regression. What are all the things that are necessary for performing calculation, performing prediction. You can just display that value also. So likewise, I have just do a scatter plot. I have visualized. So this is a label, X label, both X label. X label is in two dimension, X1, X2, and the Z label is my Y. So this is Z axis. Actually, this is X axis, Y axis, Z axis. So this is my Y and this is my X2 and this is my X1. So in this two-dimensional point, I have just visualized. So this is an example of multivariable regression. So this is the only difference. Both the variables have to be taken. So next is polynomial. Polynomial regression is also very similar to that of linear regression. You can just visualize the code. Both looking same. Yes, both looking same, but this is polynomial regression. So how this has happened? Both are same. Both are looking like same. Then where it will be a difference? So what you have studied in your theory, what is the difference between linear regression and polynomial regression? Polynomial regression grows in an exponent point of way. Even though it has taken a single variable, the single variable have to be represented polynomially. That is 2x square plus 3x cube plus 4x power 4. Likewise, it has to specify. Even though that is a single variable x. So previously it is 4x plus 1. But how here it will be specified? The same single variable x, but it is in a polynomial way. How? 2x square plus 3x plus 1. So this is the polynomial representation. Likewise, I have to define a data set. So you can see here the data set contains only one variable and one y variable. For this, I have taken a separate code. Separate code I have taken for 7th program, polynomial regression. So separate data set, that is, this is data, so contains x and x2. So for my easier understanding, I have created a separate data set. Data 1 contains a single x variable and single y variable. This is particularly created for polynomial regression. The same data set I can use for simple linear regression also, no issues. So there is no restriction that if I have used only one x and one y, I have to create a data set with one x and one y. No, you can create x1, x2, x3, x4, and I can use any one of the x variable for x value. That is also be possible as like that in the previous case. So here I have just displayed the first head. So it will display the top 5 head displaying, and what is the degree of your polynomial you have to given as an input, and you can give the predicted variable. So as I said, so now I have not having the data set here. So first thing is I need to upload the data set. So I can upload the data set here. So as I said, you just click on this folder symbol. There will be an empty space. Right click on that. Click on upload. So in that upload, I'll be having a data set created for particularly for this logistic regression, polynomial regression. So just enable that polynomial regression, run the code here. So it will ask for your data set path once it gets successfully run. So I can give data1.csv. So next it will ask what is the degree of polynomial. So I can visualize whether my data set is successfully read by using this display statement. If the data set is successfully read by our code based on df.head, that is top 5 rows will be retrieved and displayed. So what is the degree of polynomial? Degree of polynomial, anything you can give. So in the degree of polynomial, it will be calculated and this regression will be displayed. So here the error and the R square value, you can look at how it will be calculated. Those things you have studied in your theory session. What is the formula for calculating the slope, intercept, R square, mean square error and all. So this is the polynomial regression. You can see here, this is the actual value and this is the predicted value. So actual value and the predicted value are more or less very closer, which means is that our model is accurately predicting, maximally accurately predicting the variable. So this is what the case. So this is polynomial fit for degree 3. So that will be here displayed as an legend. This is the actual. This blue dots are the actual and this red line indicates it is the polynomial degree. So you can experience this polynomial regression. So it is not completely displaying. Sometimes only half of the programs are displaying. So previously it has displayed it in a complete way. And so we can look at here, it has run and it is providing the output. So after this polynomial regression, this program is about you have to experience simple linear regression, multiple linear regression, and polynomial regression. Very simple thing to understand on these 3 years. What is the simple linear is? One independent variable, one dependent variable. Multiple linear regression, one or more independent variable, only one dependent variable. And in polynomial regression, same as single regression, one independent variable, one dependent variable. Only thing is that the independent variable will be represented in a polynomial. That is x square, y square, likewise it will be displayed. And I can move to the next program, which is also a regression type, that is logistic regression. So what is your question is, implement a Python program to perform logistic regression on the data set. So what is logistic regression is that, so linear regression and all is used for predicting any of the categorical value. I hope you have understood what is a categorical value. Any value. For if x is 3, what will be my y? If x1 is 3, x2 is 2, what will be my y? Likewise. But you can understand these lines. This program reads a CSV file, any number of independent variable and only one dependent variable, that is a binary target variable. If your binary target variable is nothing but binary prediction. What is binary prediction? If the disease is present or not present, that is yes or no, 0 or 1, that is the binary target variable. So here you can see this data set. This data set, the y is categorical, 5, 9, 13, 17. This is not a binary. So here for this case, I have to apply either single linear, multiple linear or polynomial regression. But if my data set looks like this, logistic data set, looks like this. You can see this is my x1, this is my x2, this is my target variable. Look at the target variable, it is 1, 0, 1, 1, 0. That is yes or no. Binary variable 0 or 1, yes or no. Likewise, if your data set is in this way, if you're going to do a prediction for this case, then you have to go for logistic regression. So the logistic regression can take any number of independent variables and only one binary target variable. Binary target variable. So this also logistic regression. In previous case also, I have to import sklearn. From sklearn, I have to import linear regression model for all the cases. Here you have to import logistic regression from sklearn. Only that function name alone is different. This is why Python is supporting more for machine learning. Only thing that will be differ between the model is either the data set size, data set column, or the model name. Previously, it is linear regression. Now it is logistic regression. That's all. Remaining everything is very same compared to that of previous cases. So I have imported the necessary libraries from sklearn model, test train split, sklearn model, logistic regression. Previously, it is linear regression. So all the necessary libraries will be imported. Then you have to load your CSV file. You have to read that CSV file. If the file is successfully read, you have to display head. What is head? It is nothing but in the data set, if it is successfully read, the top 5 columns will be displayed. That is the purpose of data.head. Next, I have imported the data set. So in that, I have to take how many number of columns that is necessary for X. If you just exactly know I am having, so in this case, if I exactly know I have X1, X2, I can directly assign X1 and X2, one possible way. Otherwise, sometimes I may know independent variables are only 2 columns, X1, X2. In some cases, it may be 3 columns. In some cases, it may be 5 columns. Depends upon the data set that you are loading to the program. This will decide. I cannot blindly take the column X1 and X2 because the thing is that we may have n number of independent variable in this case, which I can have X1, X2, X3, X4, any number. But first data set, I may have X1 and X2. In the second data set, I may have X1, X2, X3, X4. So it depends. So better way is to use for this one is data drop column of Y. So here I can say there are 2 ways to say which are all independent variable. Either I can directly say take X1 and X2, one possible way. Otherwise, you just drop this last column. What are all the column that is remaining? Take that one as an independent variable. Both are same. Both are same. I hope you are all understand. So I can either assign X1, X2. Both are independent variable column. One possible way. Otherwise, you just drop the final target column. What are all the columns remaining you have? That you can take as independent variable. That is the case here. Data.drop column of Y, which means is that remove the last column. Remove the last column. What are all the things that is remaining in your hand? That will be our independent variable. That may be either X1, X2, or that may be X1, X2, X3, X4. That will be assigned to this X. And the final column will be assigned to this Y. Similarly, I have split the training testing. This line is for X train, X test, Y train, Y test splitting. A random splitting of training testing of 80-20%. And here comes the important. In previous, model equal to linear regression. But here, model equal to logistic regression. So for this model, I have to fit what is the X training value and Y training value. This model is fitted with X training value and Y training value. So this is for creating a model, making the model to learn with the training values. This 2 line is meant for you just creating a logistic regression model and you're just making this model to learn the values of X and Y. That's all. And prediction. Okay, my model has created and my model has learned something. I want to test my model, how it will behave, whether it is giving me the correct answer or not. That is this prediction. So this prediction is model dot predict of X test. You have some test X variable. 80 percentage you have used for this training, and remaining 20 percentage you just have in your hand for testing whether your model is predicting correctly or not. So that X test, X values you are just given as an input to your model, it will predict something that will be stored here. Your model on its own will predict some Y for this X given, that is stored here. That is stored here. And you have to plot this accuracy. How the accuracy will be calculated for this model? Yes, I have created a model. I have given some 80 percentage of data set to my model so that it learned correctly. And remaining 20 percentage, I have given just input to my model. Take this data set. So in this, consider this part alone. This part alone I have taken for training, so that my model understand if this is my x1, this is my x2, this should be my y. This is my x1, this is my x2, this should be my y. Likewise, my model has learned. This is x training and y training. My model learned. And next, these things I have to give input to my model as X testing. These values are I have to give as X testing. If this value and this value are given as an input, my model may predict something like 0. Sometimes it may be 1, or it may be 0 or 1, or likewise my model has predicted something. So this is the actual prediction that is based on the model. But this is the actual value present in the data set. So this is the actual value present in the data set. This is the model predicted value. What is the difference of these two? That is what the accuracy is about. Whether your model has correctly predicted as like that in your data set. Whether your model is correctly predicted as like that in your data set, or if there is any mismatch. If there is any mismatch means is that still more your model is need to learn something. If your model gives you the correct answer means okay, your model is learned effectively and it has given you the correct result. That is the case. So this depends. So this depends whether your model has learned correctly or whether your model needs to learn. So here this is Y prediction and this is Y actual, that is Y test. So between this, you have to calculate the accuracy. What is the accuracy score? What is the actual predicted value by the model? What is the actual value available in the data set? If both are equal, very good. My model has 100% correct. If there is a slight deviation, okay, that is okay. In such a case, how much deviations are there? That is calculated using this accuracy score. Most of you I have understood that if you are just evaluating any model means, the first thing that will be asking is what is the accuracy of your model. Accuracy is nothing but how correctly it is classified. That calculation is called accuracy. So you can just note down, no bigger formula, no bigger thing and all. How correctly your model classifies something, how correctly your model predicts something. That's all. That is called as final accuracy. So accuracy I have calculated. Confusion matrix. Confusion matrix, based on this confusion matrix only accuracy will be computed. So you can visualize how much will be taken and how much it will be correctly predicted. And this is what displaying accuracy with the 2 float decimal point. Confusion matrix display, you just display the confusion matrix. Classification report, you just display. So these are all the preliminary things in any machine learning algorithm that gets displayed on some point. So not this alone is okay. So I want to visualize my output also. So that is, I can call it as an heat map. So I want to visualize something. So that also you can do. This is what this heat map display. That is your confusion matrix display. So this is your output. So I have given logistic regression model. So logistic regression model, top 4 values will be displayed and accuracy is 100%. What you have understood from accuracy 100%? So here I have said, this is given for your model. So if this is given for your model also classifies 1010. Actual value is also 1010. Model also giving 1010. So here the accuracy is 100%. That is what it is given here. Here also the accuracy is 100%, which means my model has given everything in a correct way. So if there is any slight deviation, there will be some deviation in the percentage here. So confusion matrix. So what are all the things you want that will be displayed in this here? Precision, recall, F1 score, support. So if you want much more things, you can give confusion matrix of 5. Everything that will be calculated will be displayed here. So every value is given 1.00, 1.00, 1.00. What it means is that since your predicted value and the actual values are same, the model has given the correct answer as 100%. So this is the confusion matrix. So when my confusion matrix varies is that, so you have taken, so this is the predicted, this is the actual. Both all the 3 values that is taken for testing is same as that of actual value and the predicted values are same. This is true positive. True positive, true negative, false positive, false negative. I hope this you might have been learnt in theory classes. So based on this, 3 values taken for testing and all the 3 values are exactly calculated as such that of actual value. So my accuracy is 100%. So this is what the confusion matrix. So if the confusion matrix varies means is that it may looks like somewhat like this. So I'll show you some another example confusion matrix. You can see this is another confusion matrix example for denseness. So you have seen here, so we are having only this particular part, how it is correctly classified, how it is falsely classified. So likewise, true positive, true negative, false positive, false negative. False positive means how wrong is correctly classified as wrong. How wrong is classified as correct, that is false negative. This is a true label and this is the false label. So here this part, so totally 3166 will be calculated. In that how much items, so you have to add all this 4 cubes. So for all these 4 cubes have to be added, that is the total things that is given. Among the total, how it is correctly classified, what is the correctly wrong, correctly true is given as true, correctly wrong is given as wrong, and how many trues are falsely calculated, how much false are correctly calculated. Likewise, this confusion matrix may looks like this. You might have been studied in your theory section. So look at our confusion matrix. We are having only this one because we have taken 3 samples and all the 3 samples are correctly classified. So here no other chances are there. So this is the confusion matrix. So this example is given here in logistic regression. So this code is up to 7th program. So logistic regression is 8th one. So that is given separately here. So this is name base. So in that same program itself, it might be looking. Yeah, this is the logistic regression output. So you can see here the confusion matrix. So logistic regression data set is given as an input. So logistic regression data set is given as an input. So it is displaying top 10, accuracy 100%. So all the items are correctly classified and the confusion matrix is this one. 3 given and 3 are class 0 and it is correctly classified. Nothing is left for class 1. So this is an example of logistic regression. So I can close this later on. So next example is naive-based classification. So next year example is write a Python program to implement naive-based classifier and accuracy, precision, recall for your data set. So far we have discussed about regression. So what is naive-based classification? That is a classification algorithm. Whenever you're just hearing about this word naive-based, please keep in mind it is a probabilistic theorem. Naive-based is based on probability. Linear, non-linear, multiple linear, polynomial, everything is based on dependent, independent variable. Logistic regression, target should be a binary variable. What is a naive-based classification? It is a Bayes theorem concept, that is a probabilistic concept. So naive-based classification works on Bayes theorem, that is a probability. So for your easier understanding, I will explain what is probability. What is the actual case? I'll explain with a sample data set. So this is the naive-based data set I have taken. You can see this is the sample data. I have only certain 5 data. In real time, you may be having some n number of data. What is this naive-based data states is that probability. What is probability is that? So look at here. If this is 5 point, feature 1 is 5.1, feature 2 is 3.5, feature 3 is 1.4, this will be my target variable. If it is 4.93, this would be my target variable. Okay. Next, what is the question is that if the feature variable is 5.3 and the second variable is 3.2 and the third variable is 1.7, what will be my output? This is what the question is. This is what the question is. So you have to make your model to learn this thing. From this learning, your model needs to answer for this one. How it will answer? Very simple calculation based on probability. Naive-based probability. What probability, madam? Didn't understand. Okay. Your model will test. How it will test is that what is the probability of this one is being a target of Setosa? What is the probability of this one is being Setosa? What is the probability of this one is being the second one? Similarly, what is the probability of being the third one? What is the probability of being third one? So in this place, for example, this probability is 0.4. If this probability is 0.7, if this probability is 0.87. So what would be the answer is this would be the answer. This is what the naive-based classification. Probability. So what your model will do is that it will learn from this feature. Okay, this will learn. As it is, this will learn. If you are giving certain things as an input to your model will learn. Okay. You will give certain question to your model. Your model has to predict what value will come here. What your model will do is that it will calculate probability. What will be the probability of this one is to be a first case? That value it will obtain. What is the probability of this one to be a second case? Its value will be obtained. What is the probability of being the third case? Its value will be obtained. Which one is having the higher probability? That would be the answer, because this one is having the higher chance of occurrence. Higher chance of occurrence. Higher, yes. Higher terms of producing, yes. So this one will gives you the answer as versicular, that is the third one. Likewise, your model will answer. This is what the naive-Bayes classification. This is what the naive-Bayes classification. So the probability will be calculated based on this formula. So previously, madam, we have imported linear regression, logistic regression. So for naive-Bayes, what is the model name? Its name is Gaussian naive-Bayes. Similar to that, because that is the name that is written inside this sklearn. You can see here, sklearn contains every model that is needed for machine learning. So naive-Bayes algorithm normally given with the name of Gaussian NB inside your sklearn. So you have to import that one. Remaining everything, what are all the things that is necessary, just imported. You have to read your CSV file. This is the CSV file I have used for naive-Bayes classification. You have just imported, display whether you have imported correctly. And this also can have any number of independent variable. In this example, we are having feature 1, feature 2, feature 3 and the target variable. Likewise, your model may have any number of input variable and only one target variable. In order to identify how many input variables are there, what I can do is, so I can just remove the last column and I can make the remaining column to be set as the independent variable. If I want to identify in my data set what is the independent variable column, just remove this last column. What are all the remaining columns available? That will be our independent variable. So why? Because is that in some cases it may be 1, in some case it may be 2. Depends on the data set. I may give some other data set also as an input. So one beauty about this machine learning model is, if you have created your model only once, you can give any data set as your input. I can, now this time I can give this naive.csv as an input. Some other data set, real-time data set also I can download it from internet, from Kaggle, from free repository. And I can just give that one as an input to my model so that my model may run. That is also be possible. That is the another case. So I have to give this model as an input and I have to drop the last column. Remaining columns are independent variable and the last column will be taken as a dependent variable. Similarly, 20% for testing, remaining 80% will be taken for training. That is this line. Yes, I have to make my model the same set of lines, same set of coding for all the program. Only difference is that model name alone. So if you study only one program clearly, you can apply this for all the remaining things. Only necessary is that the name of this model alone to be correctly used. That's all. This coding, previous 2-3 codings and are all same. Only different. First is linear regression. Second is logistic regression. Here it is Gaussian and naive-Bayes. That's all. This alone gets differ. Model is Gaussian naive-Bayes and this model will be created. This model take this 2 training, X train, Y train as an input. This will learn something. That part completed. Next, I am checking how my model is predicted by giving this X test variable. So training part I have just given to the model as an input so that my model can learn. Testing X variable I have to give to my model and I have to check how it is predicted. That is stored in this Y predict. Then accuracy will be calculated against my Y prediction that is given by my model and what is the actual Y test. This is present in the data set. This is given by the model. Between this, accuracy will be calculated. And similarly, precision, recall, everything. I hope you have known the formula for accuracy, precision, recall, and all. Go through that. So here in this coding, just we need to just don't denote with that formula name alone. So accuracy score, it will calculate accuracy. Precision score, it will calculate precision. Recall score, it will calculate recall. So formula we have to know for theory point of view. In the coding, just we have to say what is the score and it will calculate. And what are all the things you want to display? Accuracy, precision, recall with the 2 decimal point I want to display. Okay. And confusion matrix also I want to display. Okay. Confusion matrix structure also I want to display. Okay. So confusion matrix predicted actual, likewise the confusion matrix along with the plot I want to display. Okay. So here this is the output. I have given logistic CSV file as an input. It will display the top n values. Accuracy here also 100%. You can ask me how it is always possible to give the accuracy as 100%. Anyone can able to answer? Why? Because is that you can look at here, our data size are very small. Our data size is very small. So from this, it will easily learn everything and it will give the correct prediction for all the cases. When there will be a deviation is that when you are taking a real-time data set, for example, pneumonia disease classification, pulmonary disease classification. Likewise, if you are taking any real-time data set, we cannot have only this 5 number of features. We can have n number of features and we can have 1000, 2000 number of rows also. In that case, if you are giving or making your model to learn, in such case, your model may slightly give some answers in an unexpected way. We cannot say every model will give you 100% accuracy. In publication results and all, you might have known that. You might be see that. Sometimes the author has specified 99.2%, 99.5%, 98%. Likewise, you might have seen. Where comes this? This is because some classifications it might be misclassified. So here all the 3 values will be taken and all the 3 values are correctly classified. So we have got the accuracy as 100%. But in real time, it maximal 99% of the system will never give 100% for real time applications. Because there may be some misclassifications, there may be some missing of data. We need to pre-process the data because the data size is large, feature size is large. So here we cannot expect 100% results in that. So that's all about naive Bayes. So this also very similar to that of previous case. So this is the naive Bayes classification. You can see this is logistic regression. And this is naive Bayes classification program. So naive Bayes classification also have given 100%. And I have given what is the test results and the classification report and the confusion matrix. So the difference of thing is that only that algorithm name. One second. Yes. Since fuzzy classification is not given in your syllabus, I have not given that code here. Yes, if the data size is large, that is I have said, for a real-time data set, we may not get 100% good. As you have predicted, it is correct. Next is decision tree classification. Write a Python code to demonstrate the working of decision tree. So what you have learned in decision tree in your theory session? So decision tree is nothing but, so what I have said previously for this naive Bayes classification. If future 1 is this, future 2 is this will be my target. Likewise, you can draw a tree-like representation. And from the tree-like representation, we may identify what will be the output. So firstly, I have to create a decision node, that is a root node. So in your theory part, you might have learned In order to draw a decision tree, the first and foremost thing is that you have to create a decision, that is a root node first. So I cannot blindly create as it is. For that, certain formulas and all. I hope you know entropy measure. Based on entropy and the gain value, based on entropy, after calculating the entropy, you have to calculate the gain ratio for each and every node. That is each and every attribute. Which one is having higher gain ratio, that will come as a root node. Then you have to go with the next node. Likewise, I have to identify what are all the node that is required to have, are required to have the higher percentage of gain ratio. Next node, that will be attached as next node. And we will be having, these are all decision nodes, and the last node is called the leaf nodes. Leaf node is nothing but that will be the answer. One example is given here. So this will be the root node. So if the salary is between this one, if it is yes, then you have to go this decision. If it is no, leave, that is decline the offer. If it is yes, I have to check the next decision, the office is near to home or not. If it is yes, I have to go with the next decision. If it is no, I can decline the offer. Next decision is if there is any cap facility. If it is yes, I can accept the offer. If it is no, I can decline the offer. So this accept, decline, and are all final leaf notes, that are all decision, that are all your classification result. Whereas the thing that is given between this salary and this one, this yellow color are all decision notes. This you can take the decision. How to set this one is here, this one here, this one in this place, based on your entropy measure. So in theory, while explaining this decision tree, you have to write entropy and you have to plot against this entropy value. And in coding, you have to use this entropy, plot tree, and export text to create this decision tree like structure. So you can see the output first. This also very similar to that of previous case. So I have used the same data set for this also. These are all the values we are having. Okay. So I have given what are all the values that want to identify. If these are all the value that is learned by the model, if this is given as an input to the model, what target value it has predicted? It has predicted the target value as setosa. So previously in A-base also doing the same, but it is based on probability. Here also it is doing the same. That is given as input independent variable, it will predict some target variable. But the target variable is based on this decision tree. It will construct the decision tree. Okay. If this is the data set, what is the decision tree? This is the decision tree. You can visualize the decision tree here. What is the decision tree? So this is the decision tree. This is the root node. This is next decision. This is next decision. This is decision. Likewise. If the feature is less than this value, if the entropy, it will calculate entropy. Entropy, this value, samples are 4. If the value is this one, then it has to comes under this particular case. Or else it has to comes under this case. Or it has to comes under this case. For Virginica, it has 2 classifications. Setosa 2 classification and versicolor 1 classification. This is the decision tree constructed based on the given data set. Based on this rule, based on the entropy measure, it will calculate for the given variable. So this is the input. So this is the input data set. It will read and display, and this is the input. So if this is the input, what will be the classification? This is the classification output. So this is what? This is the decision tree constructed for the given data set. So based on this construction, this can be pictorially represented like this, or this can be represented in this way also. Both are same. Both the value you can just visualize. This is also decision tree. This is also decision tree. This is the pictorial way of representation. This is the node or line way of representation. So based on this prediction, it has given the answer as setosa. I just identify what is the accuracy of this classification, whether it is correctly classified or there is any deviation. It is correctly classified my result as 100%. So it has correctly classified. So what is the difference in this code, ma'am? The same thing, sklearn. So here you have to import the model decision tree classifier. First linear, logistic, Gaussian naive Bayes. Here it is decision tree classifier. This is the model name for doing decision tree classification. The same thing remaining, getting the input path for your data set, displaying a data set, and setting the independent variable, setting the target variable, splitting of training and testing. And here comes the difference. This is the part where your difference is. Decision tree classifier, based on what I have to do a decision entropy. There are n number of criterion. One algorithm will take entropy as a criterion. One algorithm may take gain ratio. One algorithm may take Gini index as a criterion. So you have to be explicitly specify what is the criterion that have to be taken for building this decision tree. Then you have to train the model. Then you are testing the model. Then you are calculating the accuracy. Next, you are just displaying the result. Then visualization based on tree format, textual representation. This is the textual representation. This is pictorial representation. This is textual representation. This is the way for doing the decision tree classification. So one important point here is that, so in decision, in every algorithm, the one particular thing that gets differed is that the name of that particular model, what is the criterion we are setting for that model. So in previous, the model name differs, here the model name differs. So remaining, the way of code representation is same from the program 7th. Until now, everything is same. Creating a model, making the model learn, testing the model, predicting accuracy, displaying confusion matrix. If you want for this model also, you can just display. So next program is support vector machine. So assuming the set of data that needs to be classified based on support vector machine. Support vector machine is also a same. There are one commonality among all the machine learning algorithm. The commonality is nothing but, so everything has taken set of independent variables and it is predicting the output. Everything has taken set of input variables and predicting the output. Only difference is that each and every model is having its own advantage and disadvantage. That is not here. It will take more time to discuss that. It is depends on the user choice. For example, for any classification, if I want to use decision tree, yes, decision tree will give me the answer. If I want to use naive-based classification, yes, that also will give the correct answer. I can use support vector machine also. Yes, you can use. That also classified and gives you the result. Then what is the purpose of having this number of algorithm is that each and every algorithm is having its own advantage and disadvantage. If the number of attributes are very large, decision tree construction takes much larger time. In such a case, you can go for support vector machine. So in such that there will be a difference among each and every model. This also take, you can see here, the output will be very same. I have used the same data set for naive-based, decision tree and the support vector machine. What I can learn from here, I can use the same data set. For this data set, in all the places, I can get the value as same, prediction value as same. But when to use decision tree, when to use support vector machine, when to use naive-based classification is of user choice. How user can select that one? Based on your necessary, based on your understanding, based on your necessary, you can decide that one. So the same data set, I am just displaying the data set, test, train, predict, confusion matrix. So what is the model name for SVM? So for decision tree, it is decision tree classifier. For linear regression, it is linear regression. Logistic, it is logistic regression. What is the name, madam? It is SVC, support vector machine. So I have to import SVM, sklearn.svm, import SVC. So here the model name, these are all same, the same set of code, up to this for all the program. Importing data set, displaying, setting independent variable, dependent variable, splitting, training and testing. Everything is same. Here, instead of model name Gaussian NB, decision tree classifier, here it is SVC. So here the SVM classifier is having kernel, that is linear kernel or parabolic or hyperbolic kernel, that is of user choice. So linear, polylinear, parabolic. So if you want, you can specify and visualize the result. So the model name is SVC. And model fitting, prediction, calculating accuracy, displaying the confusion matrix. That's all. The same thing. So this also gives 100% accuracy. So I have not visualized that heat map way of representation. If you want, you can use that one. Heat map way of representation, your confusion matrix will looks like this way. So if you want to looks like this way, you have to use this display plot of confusion matrix, that is heat map point of view. So if you don't want only that confusion matrix table alone is enough, then you can go with that way of representation. Here comes the clustering. So far we have discussed about regression. First part under all regression. Second part under all classification, SVM classification, decision tree classification, naive-Bayes classification. The last part is clustering. As you know that clustering is nothing but it is a grouping. Based on the grouping, I can say what is the answer. First, what is k-means clustering? K nearest neighbor. So these are all the clustering algorithm. What it will do, so you can see the output here in clustering. So these three are in one color. These things are in another color. So these are in another color. So what it represents? So these are all the clusters. So the things that are in looks like same, which are very nearer to each other, that comes under one particular cluster. So here this is the data set. The data set I have used the same naive-Bayes I have used. So here there are three clusters. Setosa one cluster. This is another cluster. This is another cluster. Likewise, the cluster may be created. So if your final point is based on any particular cluster that is nearer, your answer will be displayed. For example, if I have given 5.2, 3.3 and 1.3, it will be nearer to this first cluster and Setosa will be the answer. If it is within this range of cluster, it will give the result as Virginica. If it is in the range of this particular cluster, it will give the value as versicolor. That's all. This is called clustering. In previous cases under all classification, the binary target, how it will be classified. So this is clustering, which means is that the nearest point will be computed and based on that nearest point, the output will be predicted. So what is the model name? So this is the k-means clustering. K-means, I hope you have learned in clustering, who have taken the clustering part in theory session, what they have taught. First, you have to identify the initial centroid. Each and every iteration, you have to calculate the new centroid. So based on that new centroid, you have to split the clusters. So based on your data falls under which cluster, you have to give the output. So likewise, it has to be proceed. So the k-means clustering work in this way. The model name is k-means. That's all, sir. So remaining these part under all the same. So here you have to use the k-means clustering. For k-means clustering, you have to standardize the data. That is, you have to group all those data in a way such that One clusters are coming to one scalar and another clusters are moved into another scalar. For that, the standard scalar have to be imported and it have to be fit for the given target variable. And you have to import the k-means model and you have to give how many number of clusters you want to visualize. If they have given k equal to 3, it will split the given data set into 3 clusters. If I have given the k value as 2, it will split the given data set into 2 clusters. Likewise, it will be performed. Likewise, the clustering part will be done and the clustering will be based on the clustering. If my question falls under which cluster, that will be the answer. If my cluster falls under which category, based on that, my output will be clusters. My output will be separated and it will be displayed. So this is the sample data set and this is the clustering options and this is the final cluster. Since I have given the cluster value as 3, so 3 clusters are given and 3 clusters centroid values are given here. So this is the first clustering algorithm. So similarly, KNN will also be there. So K nearest neighbor, which works on the same principle of K-means algorithm. So here the cluster will be grouped based on the centroid. In K nearest neighbor, voting mechanism will be followed. Based on that voting mechanism, the cluster nearer points will be identified and it will be calculated. So the 14th one is artificial neural network. So this artificial neural networks are traditional method in machine learning. This also do the same thing. So mostly this will contain different layers. Your input will be processed under different layers like input layer, hidden layer, and then output layer. And finally, it will produces the output based on the processing that is done in these layers. You can run this code up to number of epochs. For example, if your program runs for 50 epochs, how your output is, you can check. If it is run for 200 epochs, how your output is, you can check. If your output is not satisfied in a way, what you can do is that you can increase the number of epochs or you can include some optimization algorithm. What this optimization algorithm will do? This will calculate some of the important features and based on that important features, this will run. So this is the ANN program. The same data set I have taken for this ANN, which is similar to that of previous case, that is ANN.CSV. One more features I have identified. And with this feature, so I can predict the target value. So what is the accuracy and what is the loss? So you can look at here accuracy and loss. What is accuracy? Have you remember? Can you able to remember what is accuracy and what is loss? So if the accuracy is how predictably it will be classified, loss is computed over how much amount of false positives and the true negatives will be making a change in this confusion matrix that is given in this way. So you can visualize here once again. So the loss will be calculated similar to that of accuracy, how the loss. So here, since the data set size is very smaller, so here the training accuracy and testing accuracy are much difference. So here you can see the accuracy is very less compared to that of the previous models and all. See the testing accuracy it is nearer to 0. That is, it is very minimal. So loss is high. So why this has happened is that Data set size is very small. For training and testing, we have equal number of values that is taken. So here you have to change the data set size. You have to modify your number of inputs, that is training and testing variable, so that it will work correctly. And the last one is dimensionality reduction using principal component analysis. The general approach for dimensionality reduction is that in real time, you might be having n number of variables. So n number of variables can be taken as an input target, but you have to say among these four features, which are all the features that is really necessary. Sometimes some features contribute less to your target value. In such a case, I can omit that I can omit that feature. I can reduce the dimension. It is not always meaning is that I have to take always 4 cross 4 for doing this classification. Sometimes I can take 3 cross 3. Sometimes I can take 4 cross 4 for doing this classification. So this is called dimensionality reduction. How this dimensionality reduction can be done is that you have to be analyze which dimension highly contribute to a particular target by explaining this variant ratio. So this you have to calculate, and based on this calculation, if all the dimensions are need to be understood, then those dimensions have to be taken. If anything needs to be rejected, you have to be rejected. Here I have taken all the 4 dimensions and I have computed my principal component analysis. So here this is the variant ratio of 0.7, the first variant ratio, and the second bar chart is this one, this total, second one, 0.24. So the variance ratio can be calculated and it is plotted to understand this principal component analysis. This is for next level of phasing in machine learning. The first and foremost important things are all, what are all the basic regressions, classifications, and all final clustering. These are all important. As explained previously, it is of user choice to understand whether to go for regression, whether to go for classification, whether to go for clustering. It not only that choice of the user, it also depends on the type of the data set also. Based on the data set you are having, what type of real-time data you are choosing, and what is your advantage that your point of view. Some algorithm have some advantage, some algorithm have less advantage. So based on this, you have to choose your model, and you have to fit your model, and you have to make the classifications. So the concept behind every algorithm is very simple. Take the model, make the model learn, and predict the model, calculate the accuracy, display. That is visualize. Only thing differs is that model name alone. So likewise, you have to choose your data set, and you can experience for different algorithm. So I'll share this file with the organizer so that you can experience with your own real-time data set. So here I have taken a sample data set and I'm working. So I'll share this one. So for each and everything for your problem, so you can download the data set, the real-time data set from internet, and you can experience all those algorithms with that real-time data set. So you can experience how different algorithm gives the different level of accuracy. So sometimes some algorithm gives you higher accuracy, which means is that your data set is particularly more suited for that particular problem. So sometimes some algorithm provide less accuracy, but for some other problem, it will give you the higher accuracy. So we cannot say blindly this algorithm is better, this algorithm is better. It depends on the data set. It depends on the user choice of selection. You can use that data set and you can use that for different algorithm. It is the trial and error method. So if you want higher accuracy, you have to try a data set with different models so that you can identify for that data set which algorithm gives the correct answer. So I hope the session is clear for everyone. So I'll share my materials with the organizer so that you can use. So I hope it is clear. And if you have any doubt at any point, you can reach out me. Okay, I hope it is clear. Do you have any doubt? You can ask me. Thank you. Thank you for your appreciation. So I'll take this one, and if time permits, we can meet in some other session with some other real-time examples we can work it on. Thanks a lot for everyone. Thank you for your patient understanding. And I hope my material and my presentation will help you in proceeding with this machine learning. Thank you all. Yes, shall we wind up? Okay, thank you.